Okay, this is Algebra 2, Semester 2. This is Unit 8 Statistics. It's the second lesson in this unit. It's section 13.7 and factoring with GCF. We'll warm up here with the factoring. This is completely a review from Algebra 1, or it should be. The first thing that I want you to remember is recall how the distributive property works. And distributive property is probably one that you remember. You guys seem to be pretty good at it. You take this outer number and you multiply it by everything on the inside. So that would become 3x plus 12. Because you took the 3 times x and then the 3 times the positive 4. So that would be your final answer with distributing that. The next one, 3x, I'm going to draw my arrows underneath since there's more room. 3x times x would be 3x squared. Remember, both those x's have an exponent of 1 and you add exponents when you're multiplying. Plus 3x times 4 would be 12x. Next one, go ahead and pause the video and feel free to do these and then come back on and check them. 3x times x squared would be 3x cubed. Plus 3x times 2x would be 6x squared. 3x times 4 would be 12x. The last one, 2 times x cubed would be 2x cubed. 2 times negative 2, or negative x squared would be negative 2x squared. 2 times 2x is positive 4x, and 2 times 4 is 8. Okay, now when you think about how distributive property in class, I actually showed you guys how we distribute candy, and I just had a lineup of you receiving candy from me. It's like making sure that it goes to every element inside of the parentheses. Well, now what I'm going to show you is doing distributive backwards is what we call factoring. Factoring is the reverse of distributing. So now if you notice, this is the answer that we got up above. So to factor it, we would say, well, a 3 can go into there, and a 3 can go into there, so we pull a 3 out. And what's left in the parentheses, x, because 3 times x would be 3x, and 4, because 3 times 4 is 12. All of these match up the same way, but make sure that you can get them without just going up there and copying it. Make sure that it makes sense to you that in this and in that, we can see that we can pull 3 out and that we can pull an x out. Easy way to look at the variables is it's always your lowest exponent. That's a 2, that's a 1, so it'd be 3x to the first out there. And then we have x plus 4 in there. On the next one, in my rough draft I have a typo, and that should be a 6x squared. Hopefully I have it repaired on your copy, but if it's not, then make sure and change it. Again, we can see 3 goes into 3, 6, and 12, so we pull 3 out, and our lowest exponent on the variable is a x to the first, so we put x to the first out here. Now 3x times x squared would give me 3x cubed. 3x times positive 2x would give me 6x squared. And 3x times 4 would give me 12x. Over to the 4 term, the number that would go into each would be 2 because it's 2, 4, and 8, so 2 will go into each. The lowest exponent would be x to the first, but then the 8 doesn't have an x, so we can't put an x out in front. So 2 times x cubed is 2x cubed. 2 times negative x squared is negative 2x squared. 2 times 2x is 4x. And 2 times 4 is 8. So that's how you factor out with the GCF. You always look at your terms and see if there's a number that would go into all of them evenly, and then see if there is a variable in each one and take the lowest exponent of that variable. This is called GCF Factoring. Okay, now we get into stem and leaf plots, and I want to make sure that I give the notes that I have on this, so let me just turn my other pages here and make sure that I'm following along. The first thing that I want you to do on this is I want you to take these scores and put them into this stem and leaf plot. Title would be quiz scores, because that's what I've told you that these are. Stem and leaf plot, basically the stem are all the digits except for the last digit. The last digit to the right is your leaf. Leaves are always smaller than stems, so sometimes you'll even have 2 digits over here in the stem part. It doesn't matter whether you start from the smallest and go down to the largest, or start from the largest and go down to the smallest. On this one, I want to show it in this way. 0, 1, 2, 3, 4, and 5. Now, I didn't just make up those numbers. Actually, I get those numbers from the digits in the left-hand column. There's my 1, there's my 3, here's a 2, there's a 1, and here's my zeros, those that are single digit. So now, in order to make the leaf, I should look at my single digits for 0. That's my 1-digit numbers. I have 8, 8, 7, 7, 4, 3, and that's it. So I put the lowest one first. 3, 4, 7, 7, 8, 8. Now there's a couple things that I'm doing here, that one's a little bit close, that I want to mention that eliminate common errors. I never put a comma between these, and I do repeat if they happen to repeat up there, and I try to make them equally spaced. Now I mark those out. I've got 2 8s, I've got 2 7s, I've got 4 and a 3. Okay, I go to my next line. Now this is the tens column, so any that have tens up there, I've got a 14, a 19, an 18, a 14, a 12, and a 19. So in this column, I'll put in my 12 first. It was the lowest, so I put a 2 in there. 14 was my next lowest, so 4, and there were 2 of those, so 4. Then 18, and then 19 and 19. Now I mark all those out because I've got them on the stem and leaf plot. And now I go up to my 20s. I only saw one 20 up here, and that was a 21. On the 21, I simply list the 1. For the 30s, I had a number of those. I've got 35, 37, 39, 33, 32. So I list those from the smallest one first. That would be the 32, then 33, then 35, 37, and 39. So to read that, I'm picking up this stem to go with each of these leaves. Now we get down to the 40s. There's only a 41 and a 42. So I put in the 1 and then the 2. I have no 50s. So it's very important that I don't list anything here, because if I put a 0 there, that would mean that I have a 50 up there. So I simply list it without anything there. Now I do need to write a key down here. I can choose any of these to write a key from. I'll just choose my key to be the very first one. that 0.3 is equal to 3. The reason I have to show that is sometimes it'll be equal to 0.3 or 0.03. So those are real important keys to have and to always read. Now in the next one, I want you to fill it in as I do. Let's see, these are some other quiz scores. So fill in your notes. Write Quiz B scores. And let's make the first one, we'll make it go the opposite way just so you get to see one. Let's make this 9 and then 0, 1, 2, 8, 7, 4, 5, 7, 7, 9, 6, 3, and let's do 5, 2, 1. Okay, what I'd like you to do here, and I'm going to give you a key. Always read the key of a stem and leaf. 9, 0 is equal to 9.0. What I'd like you to do right now is list these scores for me. List those scores for me. Okay, so I'm going to go ahead and do that. I see a little tiny error that I made here when I put 5, 2, and then the 1. I should have put the 1 before the 2. That was kind of my mistake, but we can still read it. Listing from the highest number, I'd go 9.2, 9.1, 9.0. Now there is no 8 listed. I skip any 8s here. The reason it has to have the 8 there is because, think about it, we never have a tree with a hole in the middle of the stump. And this is just like a stem. We don't have a stem that's broken here and have the plant go on. So you still list the 8 for the order, but you show that there are none. So now we go with 7.9, 7.7, 7.7, 7.5, 7.4, 6.3, 5.2, and 5.1. Again, those are written backwards. They should be this way in order to fit with the order of the entire table. So, very good. That brings us to an end of that tape. Thank you very much. We'll see you tomorrow in class.